Okay, so these are the last 3 slides, really, from 113, okay? Well, actually 4 slides. So we skipped this example, and I said, we're okay, and then I realized that I forgot that this was a different scenario. So I wanted to make sure I talk about it. So this example was in the beginning where we're talking about which function it is based on how many differences you have to find, right? First difference linear, second difference quadratic, that kind of stuff. Now what's unique about this example is if you look at your x values, they are not increasing on the same interval, okay? So we can't just subtract. So what you want to do is, the first thing you're going to do is check to make sure it's increasing or decreasing on the same level. So this is going up by 2. This is going up by 1, by 1, by 1, okay? So you can't start by 2s and then switch to 1s. You have to be consistent. And you can do this a couple different ways, but one way is literally ignore some of those columns. As long as you have enough columns to get you to the difference that you're looking for, then I could literally say, okay, if I'm going to go by 2s, then I'm going to skip this column completely, and I'm going to go by 2 here. And then I'm going to skip this column completely, and I'm going to go by 2 here. So then I'm finding the difference from -7 minus a -11. I'm finding the difference from -3 minus a -7, and then 1 minus a -3. And all of these are 4. And that's your first difference, which means this is linear. So you have to go by the same pattern, and sometimes that means omitting some of your data. Let's say I needed to get to the second level, then I need at least 4, right? Because my first difference, I would get 3 answers from, and I would need another difference there. So if it's linear, you really only need 2 sets. But if it's quadratic, then I would need to start with at least 4 options. Yeah.
So if you could omit some, would you not just discard the first one? And
yeah, typically you want to make sure that you include the first one just to establish that kind of behavior, but the same pattern works.
So you could do just like without the -3
Yeah.
and get the same thing?
Yeah. Yeah, because it's -5 minus a -7, -3 minus a -5, -1 minus a -3, and 1 minus a -1. Yeah. Yeah.
Do you not have to divide the x?
When you're finding the differences, no. When you're finding the rate of change, yes. So if I was finding the rate of change, I then have to divide it by my 2. But when I'm just finding the differences, no, I don't need to. Okay, so then at the end of the notes, we're going to go to the real world examples. So in this section, obviously we talk about linear stuff, and but we also added in quadratic and cubic real world scenarios. So if you think about, like, a simple question might be, here's my scenario, which type of model would be the best to use to find the information? And it might just say linear, quadratic, cubic. If it's something like area, you usually have the 2 variables, right? Length times width. That means that the best opportunity is going to be quadratic. If it's something like volume of a prism or anything, there's usually 3 measurements that we multiply. So like if you think about a prism, it's length times width times height. So cubic is your best option there. Okay, there's literally like on one of the practice tests as we approach the actual AP exam, there's a simple question that just says, here's a scenario, which of the following would be the best? And if it's area, it's going to be quadratic, and if it's volume, it's going to be cubic. In that real world modeling with your quadratic or cubic functions. So example 4 says, suppose the volume of a right cylinder has height h, that is 4 times the length of its diameter d. Find the function v of r that represents the volume of the cylinder in terms of the radius. Recall that the volume equals pi r squared h. So it gives you the volume this time, right? Like I've got the formula for it. And it gives you that the height, which is your h, is 4 times the length of the diameter, which is d. So height equals 4 times d, okay? But in my equation, what's my input values?
The radius?
The radius and the height, right? So we've got height, but we've got it in terms of diameter. Does that make sense?
Yeah.
Okay, and we need it in terms of radius. How do I go from diameter to radius?
Times 2.
Diameter is the radius times 2, right? So diameter equals 2 times my radius, which means h would equal 4 times 2 times r, which means my height is actually 8r. So then when I want to plug the values in, it would be v equals the pi times my r squared times 8r, because that's what your height is. And so the model I would use is v of r, because it gives you that. V of r equals pi, well, it could be 8 pi r cubed. So that would be the model Okay, that gives you the volume in terms of the radius. So my input is the radius, my output's the volume. Okay? With me so far? All right, second part says, using the formula found, what's a reasonable domain and range for the problem if the diameter can never be larger than 12 centimeters? So first of all, domain is what? X or Y?
X.
Which is your input or your output?
Input.
Input. So what are we talking about in this scenario? The radius. What would be the restrictions on the radius, right? In every real world scenario in which you have volume, can your radius be negative? No. Can it be 0? No, because you wouldn't have volume, right? But it starts at 0. So my domain is going to start at 0 and it can't include it, so it gets a parentheses. Now the second part of this says, if the diameter can never be larger than 12 centimeters. Well, that's diameter. So the diameter has to be less than 12, right? What does that mean? The radius has to be less than? 6. Good. Radius would have to be less than 6. Can it equal 6?
Yes.
Yes, because it can never be larger than 12. So technically it could be less than or equal to 12, which means it could be less than or equal to 6. So that means my domain is 0 to 6 with a bracket on the 6. With me so far?
Yeah.
Okay. Second part is range. Now range is what? Based on the output, which is the Y, which in this case is volume. Okay? So what would be a restriction on volume? Can it be negative?
No.
Can it be 0? No. So it's going to start at 0. Okay? And how do I know what's the biggest it could be? Plug in what?
6.
6, which is my max R. Does that make sense? Okay, so I'm going to take my 8. I'm going to multiply it times pi. I'm going to multiply it times 6 to the third. So this is 8 times 216 times pi. 216 times 8. 48. 1,728. And we'll keep it in terms of pi if we didn't have a calculator. And that's what it would look like. So your max value is 1728 pi. And can it equal it? Yes, because it can equal 6. Questions? So like not terrible if we break it down into its parts and we start to understand the restrictions placed on domain and range as far as the real world goes, right? Things like volume, area, whatever are never going to be 0. They can never be negative. Things like time can never be negative. Time could be at 0 because that could be your starting point. But other than that, it would be beyond 0. Okay, so this is a really good practice question as far as your sometimes multiple choice, but also could be an FRQ AP style question. So it says a square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and the sides are folded up to form an open-topped box. So they basically give you the visual, but you had a rectangular piece of cardboard, and you want to cut out each of these little corners and then fold up your edges to make a box that has no lid on it. That's what it means by open-top box, okay? So this is what it would look like. So it says, write the volume of the box as a function of x. Well, how do I find the volume of a box? Length times width times height. So I know length times width times height is the volume. On my original rectangle, what are the dimensions? 8 by 15. So it looks like maybe this is 8. It doesn't really matter. But if I were drawing to scale, I would say that it's wider than it is tall, right? But in order to find the volume, I need the dimensions of my folded box, right? So what happened to my length and to my width from this to this? We took off an x on each side, yes? Because technically this is x, and 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 this is x. So how did that change my width? It's no longer 8, it's what? 8 minus 2x. Good. So this now becomes 8 minus 2x. And how did it change your length? 15 minus 2x. Does that make sense? This is like a tricky question, but I think if you understand it, you could do it, right? Like maybe it stumps you, but also if you start to understand it, it's not that terrible. All right, so now what's the height of this box? X, because I took something like this, I folded it up. Does that make sense? Yep, so my height is x. So my volume is 15 minus 2x times 8 minus 2x times x. With me so far? Okay, now let's talk domain. So it's got volume, right? Which means this is a real world scenario. What would be the smallest value of x you could have? 0. Can it include it? No, so it gets a parentheses. What's the biggest value x can be? Close.
4.
These two cannot equal 8, right? Because then you'd have no side. Does that make sense? So the sum of the, well, these two or these two. Sum of these two have to be less than my whole side. Does that make sense? So I would say x plus x or 2x has to be less than 8. Or there would be no leftover side to make the box with, right? Which means x has to be less than 4 on that side. On the other side, your 2x would have to be less than what? 15, so x would have to be less than 7.5. Well, both of these things have to be true, right? It can't be 5 for that one. It could be 5 for this one, but they both have to be true, which means the maximum your value could be is what? 4. Can it include 4? No. So my volume goes, or my input, which is my x, goes from 0 to 4. Does that make sense? Because I think that that's tricky. So if you're confused, it's okay. All right, how about your range? Oh, it doesn't ask for the range. All right, range would start at 0, right? Oh, we talked about the range, I think, down here, right? Range would start at 0, and then how would I know what the max range would be? I would plug 4 in. Does that make sense? Okay, so now let's graph this. It says use a graphing utility as a function, v as a function of x over the domain found in part B, and then use the maximum finder to determine the max volume such a box can hold. So I'm going to pull in Desmos just so it's on this screen. You can use Desmos or you can use your handheld for our quiz practice. So 113 is not on your quiz. It will be on your test, but not on your quiz. Quiz is just 114. But for this example, I would say use either. For when we get to quiz review, we're going to stick to the handheld.
The quiz is just
114. Yep.
I have a question.
Yeah.
For the volume, why are we multiplying by x again?
Because it's length with height. Yep. Okay, so now I'm going to type in my equation. I'm going to leave it in factored form. So 15 minus 2x times 8 minus 2x times x. And if you look at what's drawn, it's a cubic shape. It goes off the screen, it comes back down, it goes back up again, okay? So I actually have x values that supersede the 4 that we found, but it's crossing through the negative, which would mean you have negative volume. Doesn't make any sense, okay? So in real world, we'd have to stop it where it's above the x-axis, because that would be where it has volume. Does that make sense? Okay, so we'd start at 0, and then if I were to tap that point, you'd see it's 4. Okay, which is consistent with what we found for our domain, from 0 to 4. Now, in order to get the max point, I'm going to zoom out till I see the max. Now, technically, is there an absolute max on this graph? No, because this arrow is going to keep going up, right? But we want this max that falls within our domain, which was 0 to 4.
I have a question.
Yeah,
So why are we including 7.5 to
because one thing said, why are we or aren't we?
why?
Aren't we?
Yeah.
Because one part restricted it that it had to be less than 4. The other part has to be less than 7.5, but both have to be true.
So that's satisfied.
Correct. Yep. All right, so I'm going to tap my max here, and my max is 1.6667. I swear to God I didn't change this from last year. And last year that wasn't funny. And then 90.74074. So what's the x represent?
Squared.
The length of the x, the length of the little side I'm cutting out, right? And what's the y represent? The volume. So when it says use the maximum fire to determine the max volume such a box can hold. So my max volume is? Good, 90.741, and it's in inches cubed because volumes measurement is cubed, okay? And then part B or D says, how big should the cutout squares be to produce the box of the maximum volume? Well, we just said the X value has to be 1.667, right, by 1.667. And this one's in inches. So if it asks for how long does the side have to be, it's just one of those. How big is it? It could be like, it could say, what's the area of the square? You'd have to multiply them together, okay? But your X value should be 1.667 to maximize that volume. Questions? Yeah.
This is like kind of off topic, but when I try graphing it on my calculator, it says there's an error. But I think
So if you downloaded the quiz review, it is just 114. Well, some of this is AP style. Technically, it's going to get modeled like an FRQ. But it will look no different to you than a multi-step question. It's the same thing. That's what a FRQ looks like.
The AP style questions we did on this lesson.
Well, instead of it being multiple choice, it could be open-ended.
Oh, okay.
So it's the same, so there was 3 parts to 114, right? The first was running the regression, figuring out which is the best R squared, and then getting the model, and then answering questions based on it. That for sure you're getting, right? And that will look like an FRQ. Here's my function, here's my backstory on the function, here's my function itself, here's my data, right? And then figure out which is best, linear, quadratic, cubic, find the model. So that will be like part I, figure out what's best. Part I, give me the model. Part I, use it to do something with it. Use it to find rate of change, use it to predict a value, something like that. Yeah,
Did we already do regression?
we did. That's what we did yesterday.
Why is it locked in Canvas?
I don't know. We can't get it unlocked, but I can share the actual video with you. Yeah. Okay, and then the second part on 114 was our piecewise functions. Well, actually, the second part was inversely and directly proportional, which is what these questions are. And then the last part was your piecewise functions. So those are the 3 topics that are going to get covered on Monday's quiz, okay? Let's do one more practice round on our regressions. Okay, turning on stat plot. Then going mode, turning on stat diagnostic. Okay, then going to stat, edit, and I'm going to type in 12. Oh gosh, this is going to be so hard for my left hand. 12, 17, 22, 28, 35, 40, 46, 50, 56, 61. And then your Y's 10, 15, oops, a daisy. 15, 18, 16, 14, 19, 26, 35. I didn't give you this many on your quiz, just so you know. 49, 55. I don't need to spend 10 minutes typing in numbers. Okay, now what? How do I get to the regression menu?
Now we press stat.
Now you go stat, calc. I want to run linear first. So LIN, reg. Run it. And we're looking at the R squared, not the R. Careful and don't grab the wrong one there. So my linear R squared is 0.7845, okay? I'm going to go back, stat, calc, quadratic, run it again. Quad R squared equals 0.9505. And stat, calc, cubic, run it again. And R squared equals 0.9664. So how do I know which one of these is the best? Closest to 1, which in this case is cubic, okay? Then it says write the equation of the regression curve. So if you pay attention to what's in this, right, it doesn't say like if it had said function notation up here, if it had said M of S, then I would use that, M of S equals. If it doesn't say it, I don't care if you put Y equals, you put F of X equals, it doesn't matter, okay? What matters is what follows this, okay? Notice what's happening on A. What's the value for A? It's got an e to the negative 4, which means that is 6.60 whatever with 4, move the decimal 4 places. So it's 0.0007 or 0.001. You cannot round that to 0 because then it eliminates your x to the third, okay? So this is 0.001 x to the third minus 0.0445 x squared plus 1.162 x plus 3.511. Still with me? Yes. Okay, then it's going to ask you to answer questions based on this. So we want to store that. So I'm going to run it again, and this time I'm going to store it. Cubic. I go down to where it says store, REGEQ, and I type in the y1. And now it stores that equation into y1. So what we don't want to do is use our rounded equation to answer questions because it's less accurate. What we do want to do is use the one that's stored in the calculator because it keeps all those decimals you don't see. So if it says use the equation to predict the mileage of a car with a speed 55 miles per hour, okay, what is that? Is that your input or your output? Your input. So I'm doing y1 of 55. So second quit, alpha, trace, y1, 55. And I get 42.336. And this is in, it says miles is in miles per gallon. So this would be miles per gallon. And then 4 says what's the average rate of change from 42 miles to 58 miles per hour and include the units, okay? So I'm going to do y1 of 58 minus y1 of 42 over 58 minus 42. So alpha y equals gets the fraction, alpha trace gets the y1, 58 minus alpha y1, 42 over 58 minus 42. And this is 1.695. And what's the unit on that? This would be, this is it, right? Like if it's output per input, then this is miles per gallon per miles per hour. Okay, so your input was your miles per hour and your output is your miles per gallon. Let's say it had said, what does that mean in this context? So if you're describing it, let's go back to B or 3. What does this mean in this context? This means if you're traveling 55 miles per hour, right, then your output, which is your miles per gallon, is 42.336 miles per gallon, okay? If it's talking about rate of change, then you have to give the interval on which it is. So from 42 miles per hour to 58 miles per hour, the rate of change is 1.695 miles per gallon per miles per hour. So you got to make sure you're confident in not only finding the data, but explaining it in terms of the context, okay? Questions?
How many questions like this are on the test?
On the test, I haven't made yet, but on the quiz, there's one big one like this with multiple parts. And then you've got multiple parts on a piecewise function, multiple parts on a inversely, directly, that kind of thing. So there's like 10 total blanks. Yeah, that's it.